All right, today we're going to take this to the next step. So on Monday and Tuesday, we talked about systems of linear equations. To recap that, today we're going to move on and talk about systems of nonlinear equations. I put the nonlinear in parentheses because sometimes one of the equations in your system will still be linear. Sometimes it won't. That's okay. It's still a system of equations. So in this first example, the black equation here, negative x minus 2y equals 130. We know right away that that is going to be linear because the degree in this is 1. So we're going to focus on graphing in the calculator for this. So in order to put this into the calculator, we need to get it into slope-intercept form. So I'm going to go ahead and solve for y. Divide everything by negative 2. So now that is in slope-intercept form. So if I was going to do a rough sketch, I know this has a negative slope. So I know it's going to be something like this, just a quick rough sketch. The second equation is a quadratic because it has a degree of 2. So remember, this is what we call even. And our leading coefficient here is negative. So this has a negative leading coefficient. So if I were to draw a rough sketch of this, I know it's going to look like this. But we definitely need more than a rough sketch in order to solve this. So remember, to solve any system of equations, we need to know where the equations are overlapping or intersecting. So this is where the calculator comes in. So again, if you have not already downloaded Calculate 84 for your iPhone, Wabbit Emu for your Android, or figured out how to graph on Desmos, you will need to figure out one of those three things so that you can definitely graph. All right, so in order to graph on the calculator, I want to do a quick run through and show you how to do that in case you are still unsure. So our first equation here, we had to get y by itself. Okay, so we did that. So we're going to click on the y equals, and we're going to type that in. So that was y equals negative 1/2 x minus 65. Our second equation was the quadratic, and that was already in standard form. So I'm going to go ahead and type that in. Our equation was negative 3x squared plus 4x plus 1. Now you may have remembered that when we were talking about quadratics before, sometimes the calculator gave us a little bit of trouble seeing the curve. So I'm going to hit the zoom button, and then I'm going to choose 0 for zoom fit. Okay, so we can see the quadratic here is in blue, and our linear is in black. So we can see that the blue and the black are actually intersecting each other 2 times. So to find that intersection, we're going to go to second trace, and if we arrow down, 5 is the intersection, so select 5. So it's asking me, are we at our left bound? So we're going to have to go through this process 2 times because we do have 2 solutions. So get it on the left, hit enter, shift it over to the right, hit enter, and we can see at the bottom of our screen there we have an intersection at negative 4, negative 63. So that is one of our solutions. Now I'm going to go in and do second trace intersect again. And I'm going to go over to the other intersection that we have and do the same thing. So now our other intersection is at the point 5.5, negative 67.75. So those are the 2 solutions for this system of equations. All right, so in order to graph this one, again, we're going to go into y equals. Our first equation is x to the 3rd plus 5x. Our second equation is 5x plus 1. So we can see that first one is going to be a cubic, and our second one is a linear. Again, I'm going to go to zoom 0 just so I can get the best possible picture of this. So we should be able to see the blue is our cubic function, and the black is our linear function. So we do want to find where they are intersecting. So I'm going to second trace, intersect. I'm going to come all the way over here, so I'm on the left side of it. Go all the way over here, so I'm on the right side of it. And it says they are intersecting at the point 1, 6, if we round that. Let's look at one more example together. So in this last example, again, we're going to go to y equals. We're going to get these equations in here. So the first one we had was y equals x to the third. So this is another cubic. And then we had y equals 5x squared minus 5. So this one is a quadratic. So I'm going to go to zoom fit so we can hopefully see what's going on here. And I want a little bit better picture there. So I'm going to take my window and I'm going to change my y min so that it's not quite so large, and my y max. Okay, that is a much better picture. So there we go. So we can see that the blue is the cubic and the black is the quadratic. So we can hopefully see that there are two spots where these are intersecting, which means we're going to have two solutions we need to find. So I'm going to do my second trace and then 5 for intersect. And I'm going to move over here. Again, we're going to have to do this one 2 times just because there are two solutions. So we have one there at negative 0.9, negative 0.8 if we round to the 10th. I'm going to go into second trace, choose 5 for intersect again, and do the same process but with the right hand 0. So now we see we have one at 1.1, 1.5, again if we're rounding to the 10th. Let us know if you have any questions. Have a great day, guys.